Okay. So we understood what is serial schedule. Okay. Okay. So now we understood what is serial schedule. Let's understand what is serializable schedule. What is a serializable schedule? A schedule, yes, is serializable. When do you call it as a serializable? If it is equivalent to some serial schedule of the same end transaction. If I call this as a schedule which has 3 transactions or any number of transactions, now, as I've already told, we have these interleaved operations, right? We have these interleaved operations. Now, what they're saying here is, when do you call this schedule is serializable? When it is serializable, when the final output, now there is only one object's output here, right? What is that object? X object. When the final output of the X is equivalent to any order of serial order, then I call it as a serializable schedule. Did you understood? Now once again I'll repeat. If I say it is Y, okay, transaction 2 has working on the Y object, transaction 3, this is transaction 3, is working on Y object, transaction 1 and 2 is working on X object. Now, once you complete this schedule, I will get one value, as we've already resolved, of X value and Y value. Say if I get X is equal to 20 and Y is equal to 30 in this schedule, when I execute this schedule, if I get the final output of X and Y like this, then this X and Y should be equivalent to any one of the serial order. It can be any one. It is same. This value of X and Y remains same when I execute the serial order of this transaction. Why I'm calling to some serial order? Because when I say serial order, I'll have too many serial order. Either it can be T1, T2, T3 is one order, T2, T1, T3 is one order, T3, T2, T1, T3, T1, T2. I have many. I think I'll get 3 cross 3, 9 order, serial order. I don't have to check for all serial orders. Out of 9 serial order, right? Out of 9 serial order, if I get any one order, any one serial order's value is same as this interleaved execution value, then I call it as a serializable schedule. Is that clear? What is serializable schedule? Right. Why they are coming up like this? Practically, if this follows, then I can say my interleaved execution has gone correct. Just to ensure my interleaved execution is correct, we are now practically analyzing when my interleaved execution will be correct, when one of the serial orders value should be same. Do you just think logically? Do you agree this or not? One after the other, when you execute, there will be no problem at all. Once I finish my job, you read what is that I have booked or what tickets, you will get a data, the other one will be. There will be no problem in error in data errors, right? When there is no problem, there will be 100% no problem in a serial order. So hence, we are comparing that order's value to the serial, interleaved execution. And we are ensuring further when we go, to make the value same as a serial order, what all the steps we need to take, that is there in your concurrency control in your second chapter. What is that step I need to take? This is a guaranteed. This should be there. Is it clear? Any doubt, you can raise your hand or you can ask me. What is serializable? Okay, next. Now, we will This is a schedule they have given. The schedule A. Schedule A is what kind of a schedule it is? What kind of a schedule? Serial or interleaved schedule? Schedule A. Schedule A is a serial schedule. We call this as a serial schedule. What is schedule B? What is the serial order it is? T1 is executed first, followed by T2. This is my order. What is a schedule? What kind of a schedule in schedule B? It is also serial order. This is also a serial schedule. What is the order of this schedule? T2 has executed first, followed by T1. The order of the schedule is T2 and T1. T2 executes first, T1. What is the schedule C? We call it as an interleaved schedule. So that means some operations of the T1 is interleaved with T2 operations, right? Both schedule C and schedule D are the interleaved operations. Right? Yeah, okay, fine. So now you understood what is serial schedule and interleaved schedule. So what is that serializability they say? You have seen the interleaved. Interleaved also can happen in many ways. See, the operations are same here, but schedule C and schedule D is interleaved in a different way. The operations has interleaved in a different way. So when do I call this schedule is serializable schedule? When the output of this operations. So what are the operations I have here? The final object operations is X and Y. The final output of X and Y should be equivalent to how many order it will have, serial order. It's only 2. That is schedule A and schedule B. So either the output of schedule C should be equivalent to either schedule A or schedule B. If the output of schedule C, that is X and Y, final output of X and Y is equivalent to schedule A and schedule B, then I call it as a schedule C is serializable. Otherwise, I call it as a non-serializable. It is not matching. Hope you understood about the serializability. Now, our main concentration is conflict equivalent and conflict serializable. Let us see what is result equivalent. Result equivalent is two schedules are called result equivalent if they produce the same final state of the database. Very simple. These two are schedules. Take any schedule. Schedule A is also, I call it as a schedule. B is also schedule. It can be any schedule. But that is a serial schedule. This is an interleaved schedule. But I am least bothered. What is it? Whether it is a serial schedule or an interleaved schedule. Now it is a schedule. Two schedule. When you call it as a result equivalent, when the final value of X and Y. Now see, C and D is working on the same operation X and Y. When do you say schedule C and schedule D are equivalent? When the result are same. At the end of the schedule, if the result is equivalent, then I call it as a result equivalent. Very simple. Now conflict equivalent. It is similar. Two schedules are set to be conflict equivalent if the order of any two conflict operations is the same as the both operations. What they say? The order of the conflict. Here I have, what is the conflict operations? Read, write, write, read, write, read. Now you can see I have a read of X followed by write of X. So if you find the order also here, conflict orders, that is, you have a read of X followed by write of X, or you have a read of Y followed by, if you see any other conflict I don't have any other conflict in schedule C. I have the conflict is this. But here it is write, read, and here it is read, write. So conflict two schedules are said to be conflict equivalent if the order of any two conflict operation is the same in both schedule. So order also should be same, but here I think it is not, sorry, it is not a same, because here I have a read operation followed by write. So here I could see read write conflict. Here I could see write read conflict. So the order is not same. Hence, I can't call them it as a conflict equivalent. They are not equivalent in their conflict operations, right? So that's a conflict equivalent. Now, very important is conflict serializable, where we check it in the problem. What is conflict serializable? A schedule S is said to be conflict serializable if it is conflict equivalent to some serial schedule S. Okay. Conflict serializable. A schedule S is to be conflict serializable if it is conflict equivalent to some serial schedule. So that means what is some serial schedule? Now I'll just use a different color here. Now we know that here, I'll compare with schedule C to A and B. So we know that schedule C and schedule D has only two orders, either T1, T2 or T2, T1. And both schedule C and schedule D operations are same as our schedule A and B. So let me see schedule C. So if it is conflict serializable, what it is? It is nothing but if I have read and write operation, just I have to check whether the read and write conflict I have. Yes, read conflict from the T2 operations and read write conflict from T1 operations. Sorry. Right and right. Or I can also pull here this is the operation. Read of X read of X I have, and then here I have write of X. So I call it as I have a read write conflict. So even here I have a read write conflict which is followed by T2 to T1. Here also it was T2 to T1. So I have a read write conflict. Hence it is conflict serializable because the conflict is equivalent to one of the serial order. Being serializable is not the same as being serial. Both are not same. Serializable is different, serial is different. Okay. Being serializable implies that the schedule is correct schedule. So what do you mean by that? They're not saying, the definition of serializable is the output of interleaved execution should be equivalent to any one of the serial order. Because we are comparing to a serial order, it doesn't mean that serializable is a serial. No. Serializable implies, what does actually tells us? It is confirms that the schedule is correct. If this happens, if this is true, then the schedule is perfectly correct. That is what it is trying to tell about the serializable. Okay, so always serializable will keep the database consistent, correct data, it is telling. The interleaving is appropriate and will result in a state as if the transaction were serially executed. So serializable ensures that result will be properly executed, right? So that's the concept of serializable. So what happened? Now our main goal is that what we need to do? We need to ensure serializability. That is the main goal here. How do we ensure every interleaved transactions or every schedule means it is interleaved with too many transactions. Every schedule should have the serializability. Serializability will tell you it is a correct executions of the interleaved transactions. So that means serializable schedule means what? It is a correct schedule. Non-serializable schedule means it is not a correct schedule. I will get a wrong output. Then wrong output of the final X and Y value. Then it is not a correct concurrent execution of a data. So now what is my final goal? I have to keep all the concurrent transaction or the schedules to maintain a serializability. That is the main goal. So what did they do? Is that manually, is that possible? Keep checking with all the serial. Just imagine if I have a schedule which has a 10 transactions concurrently executing, and I have to find out one of the combinations. I'll have 100 combinations there. So it's very difficult to, practically when I think, it's very difficult to approach. So what did they do? They came up with the, obviously for this, we have to ensure this. We have locks with two-phase locking. That is what we have in the next chapter. To ensure serializability, we use a concept of locks, which we call it as a two-phase locking. But now, before that, to check whether a view equivalence, view serializability, all you learn on your own. Okay, it's all again the same thing. Too many, what I can say, definitions that you can learn. It is similar to this. Let's concentrate on the problem. So now, but if we should also get to know that immediately any algorithm to check whether the schedule is properly serializable or not. So that is where the algorithm came into picture, and that is where you will solve the problem. So what is the algorithm? Just to check whether the schedule is serializable or not. What do you mean? That means what? Checking the schedule whether it is correct or not, whether it is 100% correct execution of data. The final data, what we are telling, it is perfect if it is serializable. Otherwise, it is not perfect. So how do I check? They have come up with an algorithm. So this algorithm we need to know. So what is that algorithm is? Looks at only one read item and write operations. Construct a precedence graph, a graph with directed. We need to construct a graph for this. And edge is created from Ti to Tm if one of the operations in Ti appears before conflicting operations in Tj. The schedule is serializable if and only if the precedence graph has no cycle. So what do you mean by if the schedule is serializable? Andre, if you say the schedule is perfect, then what you should have? The graph should not have any cycles. There should not have a cycle. If there is a cycle, then it is not serializable. Is that clear? Now, if it is serializable, then what is it they ask? Then which is that? How do you say it is a serial? Or if it is serializable, because we are checking with the graph. If it is serializable, then can you tell me to which output, serial orders output it is matching? To say, that's why when you check serializable, you will actually tell which is that serial order where the output is matching. Which is its serial order to which the serializable schedule's output is getting matched. Is that clear? That's all we need to check here. Now let's go with an example. So let's go with an example. So here we have the same example what we have taken. It's a very simple example. How do I go with the graph? Now I'll go for A. We know it is a serial, but let's just learn how to write a graph. Okay. The schedule A and schedule B is actually our serial order, right? It's actually our serial order. So even though it is a serial order, let's learn how to write a graph. So now I'm writing a graph for A. Okay. Now how many transactions you have? 2 transactions. To write 2 transactions, T1 and T2. T1 and T2. Check with the conflicts. Not necessarily the conflict should be immediate. Okay. Just find out the conflicts. Okay. That is, see, I don't have Y here. Y in T2. So it should come with X. So the conflict is read item to write item. Isn't it not? So which is that first one? The conflict operation started from which transaction? That is T1 transaction. From T1 transaction write operation to T2 transactions read operations. So that means from T1 transactions write operations to T2 transactions read operation. Both are operating on the same object. So the graph will go like this. Yeah, you could see one more, which is that from read item X to write item X. Both are same now. Both operation is same. Both this is operation. Now I'm not bothered whether it is a read write or write read. If it is conflict, the graph has to, the edge has to go from the node, right? So both the operations starting from T1 and going to T2. So that means both my operations is starting from, so you just use only one operation if that is the case. That's all. Both combining, if you write one, it is over. Okay. So now this is how we will draw the graph. Now let's come back to the second one. Second one. Again, how many transactions I have? T1 and T2. Now, what is I have a read of X followed by write of X. This is first. And same followed by write. It is the same thing. So I have, this is a conflict read, right? From when? T2 to T1. So this is how we write a graph. Right? So now schedule C. Now we will, it is interleaved. These two, schedule A and B, is a serial schedule, right? Irrespective whether it's a serial schedule or not, we are checking it. Now what are we concluding here? What are we concluding? If there is no graph, right? So no graph. No graph. When there is no graph, what do I call this schedule as? There is no, sorry, is this a no graph? No cycle.
No cycle.
Yes, it's no cycle. When there is no cycle, I call it as a, this schedule is serializable schedule. If it is serializable, so you should write this is a serializable schedule. If it is serializable schedule, what is an equivalent serial schedule for this? What is an equivalent serial schedule for this? The equivalent serial schedule, how do you check? I will just tell you, I think next problem, I'll give you the definition also for that. Which node does not have in degree, which node does not have in degree edge, or which node has in degree 0? What do you mean by in degree? See, in degree of edge, this is in degree. Coming to us, T2 has in degree of edge, how much? 1. T1 has 0. No edges going to that. There is no edge coming to me. So in degree of the edges for me is 0. So T1 does not have any in degree of edges, so it is 0. That means whichever the node has in degree 0, start with that node. How do you find the serial order? So serial order is T1 first. Cancel that node. Next in degree, when I cancel this, then which is that node? Whatever the node is, outgoing nodes from the T1 should be cancelled once I take the T1 here. Then in degree is T2. So you can see the order is actually serial order is T1, T2. Because we are executing serial schedule only. So that's why we could able to confirm here. Okay. Now I'll not go for schedule B. Let's not go for serial schedule. Let's go for interleaved schedule. Right? Now interleaved schedule. Interleaved schedule is also I have T1 and T2. 2 transactions. Now let me find out the conflict operations. So conflict operation is one is from read and write. So it is always better. Either you go for read and write or write and write. Both are same. Right? One starts from, always go from the operation of the starting transactions. Otherwise you will get confused when it is a very big transactions, very big schedule. So from read I have got write, that is from T1 to T2. T1 to T2 one I got. Now immediate next one is what? Read item of X. Don't go in between all this, you will get confused. One after the other you go. read item of X. Take read item of X followed by, say, I have write item of X here. It is a conflict, right? So that means T2 to T1 I have. I got it. But don't, sometimes we'll have many, what I can say, more marks for this. So complete. Here we don't have much. T1, T2 over. It's story, only the story between T1, T2. Either from T1 to T2, it should go T2 to T1 over. So I think you don't have to find multiple times. Any time you get, it is the same thing. I'm end up here. I'm done here. Now the graph is cyclic here, right? The graph is cyclic. I will write, there is one more problem where I will write step by step. Here only to understand, just understand. The graph is cyclic. Once the graph is cyclic, what do we say? It is not serializable. When it is not serializable, do I need to check for serial order? No. When it is not serializable, it is indirectly telling if this schedule does not match to any of the serial order. That means I will not get any equivalent serial order for this. So the problem is over here. I can't go for any serial order to check for any serial order. Now let's check for this quickly. Schedule D, T1, T2. T1, T2. I have T1 followed by, see, I have T1 followed by T2, right? That's all. This also it comes with T1 followed by T2. That's all over. Only once I have to take those conflicts. Which order? Do I have any conflict from T2 followed by T1? No, because T2 is working on X object, T1 after that last operation. This operation is working on Y object. So both are not conflict here because both are working on different objects. There is no conflict. So the graph here is only this much. So now, as the graph have no cycle, then this is a serializable schedule, right? It's a serializable schedule. Now, if I get a serializable schedule, now I have to check for the equivalent serial schedule. So let's check what is a equivalent serial schedule. Equivalent schedule, what is the in degree? In degree, which node has 0? T1 has 0 in degree. Cancel the outgoing nodes. What is the next one? We have only 2. So the order which, see, I can have a 2 order, T1, T2 or T2, T1, but out of these 2 orders of schedule D, which one's output is matching for this schedule? T1, T2. Is that clear? So now, don't worry, we will go for the next one. Oh my God, so fast. Okay, I think we can solve quickly now. We have 10 minutes. We can solve now quickly. Now I'll just give you steps how to actually a little bit how much you should write. Anta. This is an example saying that identify. This is a simple one. One problem if you solve and everything you will understand. We don't have to solve multiple problems. Identify whether a given schedule is conflict serializable or not. So they say conflict serializable or not is nothing but whether it is a conflict, you have a conflict or not. Fine. So I have this operations. So now, first I have to check what graph. The precedence graph, we call it as a what graph? Sorry. Precedence graph. The precedence graph for the above schedule, we need to talk it as a schedule, above schedule. The precedence graph for the above schedule is, now how many schedules we have? T1, T2 and T3, right? So now find out here, see from T3, read and read I don't have anything. Start from T3 to other operations also. From T3 what I have? read and write I have from T3. So T3 to T1, I have conflict. Now come from T2. When you have 3, 4 more, go with 1 and check for all the operations. So all the transactions. Read operation from T2 to T3, you check first. Yes, I have on the same object. T2 to T3. Next, I was in this itself, R of X in T2. From T2 to T1, now check for T1. T2 to T1 also I have. So that means T2 to T1 also I have. Is that clear? Now check for T3. T3 to T1 I have. We have already done. See, T3 to T1 we have already done, right? T3 to T1 we already have. We have done it. So we don't have any other. Now come for T1. Operation one by one, whichever the operation. Read of X I have. Do we have anything after this? No. Do we have anything after the write of X down? We will not go up. We will not go up. The conflict only comes when it is down. So we just have to look down. We can't keep again go match on upside. Okay. From top to bottom, that you remember, always from top to bottom will be a conflict, not from bottom to up. Once you have already updated, there will be no effect to the object which has already made the changes, right? From bottom to top, we will not go. From top to bottom, we will go. So this is my final, done. Please remember this, from bottom to top one will not go. Always from top to bottom, we will check for the conflict. Now this is my graph. So what does this graph says? There is no cycle. You can write, hence it is conflict serializable, or you can say hence it is serializable. Why they are telling conflict serializable? Because still we have not gone for the lock system, two-phase locking. Only when there is a lock, we will not see any kind of a conflict. Here, what if, because we got a conflict and then we are checking the cycle graph, right? Read, write. Those conflict will be similar to the one of the serial order. So that's why it is conflict serializable. If they don't give conflict serializable, then talk with respect to serializable. That's all. Hence, it is conflict serializable. And the equivalent conflict schedule, or you can say what, because the question is having conflict. So if there is a conflict, read write conflict, I will have a same conflict in the schedule. That's what they meant here. If they don't use conflict, then without conflict you use conflict equivalent conflict schedule. Equivalent conflict serial schedule is. So how do you need to check this? I will just use on the same graph. How do you need to check this? Which node has in degree 0? T1 in degree is how much?
T2.
Yes. T1 in degree is 2. 2 edges are coming. T3 in degree is 1. T2 in degree is 0. So the node which has in degree 0, take the first. Once T2 is found, listen, once you make this graph, please don't work on the same graph. To find the schedule, please write once again, T1, T2, T3, write the graph, and then please show how you have got the serial order. So you just say the T2 in degree, the node T2 in degree of edges is 0. Hence, take T2 first. So I will just write here, I have taken T2 first. Now what I have taken T2 first, cancel T2. Once you cancel T2, cancel the respective edges which is outgoing T2, because we have removed T2. Once you cancel the edges of node T2, then you check what is the in degree remaining now, after cancelling these two edges, T1's in degree is how much? 1. T2 in degree, T3 in degree is 0. Now the next order comes to T3. Cancel T3, cancel the edges, next T1. So the serial order is T2, T3, T1. Hence take T2 first and cancel the node T2. The handwriting is not coming better. Some problem here. And cancel the node T2 with node T2 and the respective edges. Oh shit, I don't know what's the problem here. Outgoing respective edges, outgoing the T2, right? That's the first point. Second point is next find the next oh my god, we are running. If you are end up, just we will restart. I just need 5 more minutes, that's all. Next, in degree of T3 is 0, followed by T1. Just fill up this. Followed by T1. Shit. So the final serial order is T3, T2, T3, T1. So is that clear? Yeah, I think we will go off. We will just see one more, maybe just 5 minutes. We will just see only the 5 minutes. Let's check here. It is the same problem. Schedule. I think you know when there is a schedule, how do you need to check? So how many transactions I have? T1, T2 and T3. How do you write the transactions here? R1 of X followed by W1 of X followed by W of X from transaction 1 followed by W of X. If you come up with the transaction, concurrent transaction like this, then this problem is same. You just have to write the schedule like this and then solve it.